Good morning, children. Welcome back to our math session. Today's topic is Introduction Part 2 and Exercise 14.2 of Chapter 14 Factorization. So, let we start. Factorization using identities. Now, let us look at type 3, that is factorization using identities. So, what are identities? Do you remember what we have learned about the three standard identities? That is a plus b whole square, a minus b whole square, a square minus b square, right? These three standard identities we already learned in algebra, right? And we are even proved these identities also, isn't it? Now, let me see how can we make factorization a lot easier using these identities. So let us take one example. So let's say you have an expression like this, a square plus 8a plus 16. So how can you factorize this? Now, if you find it to factorize in this case, it's very difficult because you have a square is a quadratic form, that is a to the power 2, right? Second term is like a linear, that is a to the power 1, and third term has no variable. So it is little bit difficult, right? So it is very difficult to factorize this the way we were doing in type 1 and 2, isn't it? So what we do here, now this can be written as a square, right? 16 can be written as 4 square, right? And 8a can be written as 2 into 4 into a. So 2 4 into a is 8a. So you can write it in this form, right? And what is this? This is a square plus b square plus 2 into a into b. That means a square plus b square plus 2ab, which is equal to a plus b whole square. That is a plus 4 whole square, right? So what is this? A plus 4 whole square is nothing but a plus 4 into a plus 4. So this is the factor form of this expression, right? So you have been very easily able to write this algebraic expression in the factor form, right? So that is we have factorized it. So it was pretty simple, isn't it? Now the only thing here is how would you know that this particular expression will fit into this particular identity? Now there are certain tricks to identify that. For example, whenever you are given an expression, when you see that there are a total of 3 terms, and out of those 3 terms, 2 terms are perfect squares. So I hope all of you know by now what are perfect squares. A number which can be written as a square of another number. For example, here 16 is a perfect square because you can write 16 as 4 square, right? A square is a perfect square because we can write it as a square of a, right? So in this particular expression, you see you have 3 terms, out of which 2 terms are perfect squares. And third term should be such that it fits into this formula, that is 2ab. So the first thing that you will be looking for is if you have 2 perfect squares out of 3 terms or not, only that criteria satisfy, means only then you look for the second criteria, like middle term should fit into the format of 2ab. Now let us look at one more expression, 49x square minus 36. So do you have any 3 terms here? You are having here 3 terms? No, you do not have 3 terms, right? Okay, fine. So what do we do here? But at the same time, you see that both these terms are perfect squares because 49x square can be written as 7x whole square because 7 into 7 is 49. X square is again the square of x, right? Again 36 can be written as 6 square. So both of these are perfect squares. So this is in the form of a square minus b square. So a square minus b square is equal to a plus b into a minus b, right? And is the factor form, that is 7x plus 6 into 7x minus 6. So this is again pretty simple, right? So just by looking at the algebraic expression, spend a few seconds trying to see in which format that expression is, so that we can identify which identity it will fit into, right? Perfect. Now, let us try some examples. Now you have 49y square plus 84yz plus 36z square. So here you have three terms. So there is a possibility for the first and second identity, right? So out of these three terms, two should be perfect square, right? So let's check the doubt. If you look at 49, it is a perfect square because 49 is 7 square. So 49y square will be 7y whole square. Similarly, 36 is a perfect square, that is 6 square is 36, right? So 36z square would be 6z whole square, right? Okay. First criteria is satisfied. Now we see middle term. So does this fit in the format 2ab? Here 7y is your A and 6z is your B. So 2 into 7y, which would be 14y. So 14y into 6z would be 84yz. Yes, of course, this fit into 2 into A into B. So therefore we can write it as A plus B whole square. That means 7y plus 6z whole square. Right? Now, let us look at one more example. So here also you have three terms. What is the example? P square minus 10p plus 25. But at this time the middle term has a negative sign, right? So there is a possibility that it might be to the standard identity of a minus b whole square, because p square is actually a perfect square of p. 25 is also a perfect square of 5, because it is a square of 5 and 10p can be written as 2 into p into 5, that is 2ab. So this can be written as a minus b whole square or p minus 5 whole square, right? So this way we can find the identity, means we can find out the factorization by using the proper identities. Clear? Okay. Let's start question number 1 of exercise 14.2. Factorize the following expressions. First question is a square plus 8a plus 16. So here we can say that three terms are there. So we have to see any two terms is in a perfect square form, right? Yes, here we know that a square, that is the square of a. 16 is the square of 4, right? And in between means the middle term should be in the form of 2ab. So here a we got a, b we got 4. So 2ab means 2 into a into 4 means 2 4s are 8. 8 into a, 8a. Yes, correct. So we can write it like this: a square plus 2 into a into 4 plus 4 square. That means a plus 4 whole square. Which identity? First identity. A plus b whole square is equal to a square plus 2ab plus b square. Clear? Now second one. P square minus 10p plus 25. Here also three terms are there. So let's see any two terms are having a perfect square. Yes, p square means the square of p. 25 means the square of 5. In between, we can see that 2 5s are 10. 10 into p, 10p. Yes, right. But in between sign, what is there? Minus. That means it is the identity of a minus b whole square. That is a square minus 2ab plus b square. So we can write it as p square minus 2 into p into 5 plus 5 square. That means p minus 5 whole square. That is p minus into p minus 5. Okay. Now third one, 25m square plus 30m plus 9. Here also three terms are there. So we can see any two terms are having perfect square. First one 25m square. Yes, this is the square of 5m, right? 9 is the square of 3. So this is also in the form of a plus b whole square. So that is equal to 5m whole square plus 2 into 5m into 3 plus 3 square. That means 5m plus 3 whole square. That is equal to 5m plus 3 into 5m plus 3. Now fourth one, 49 y square plus 84 yz plus 36 z square. This also having three terms. So let's see any two terms are having a perfect square. Yes, 49y square, that is the square of 7y. 36z square, that is the square of 6z. Right? So we got in between plus sign is there. So directly we can say that this is the square of, identity 1, that is a plus b whole square, that is equal to a square plus 2ab plus b square. The middle term is 2 into 7y into 6z, that is equal to 84yz. So the answer will be 7y plus 6z whole square. Right? Now fifth one, 4x square minus 8x plus 4. Here also first term 4x square, that is the square of 2x. Last term 4. 4 is the square of 2. Middle term 2 into 2x into 2. That is equal to 2 to the 4, 4 to the 8, 8x. So this is second identity, that is a minus b whole square is equal to a square minus 2ab plus b square. So answer will be 2x minus 2 whole square. Right? Now sixth one, 121 b square minus 88 bc plus 16 c square. Here also first term we can see that 121b square is the square form of 11b, right? Then 16c square is the square of 4c. So we can write it as 11b whole square minus 2 into 11b into 4c plus 4c whole square. So that is equal to a minus b whole square. So 11b minus 4c whole square. That is the answer. Now seventh one, L plus m whole square minus 4lm. Here in the question it is given, you have to expand L plus m whole square, right? So we can expand it first. L plus m whole square means a plus b whole square. A square plus 2ab plus b square. So L square plus 2lm plus m square. Then minus 4lm. Now you can see that here plus 2lm is there, minus 4lm is there. So if we subtract that, we will get minus 2lm there. So now we got the expression like this, L square minus 2lm plus m square. Now see, now we can factorize. First one L square, that is the square of L. Last one m square, that is the square of m. Minus sign is there, that means a minus b whole square. So L minus m whole square is the answer. Now last one, a raised to 4 plus a square b square plus b raised to 4. So here a raised to 4 we can write as a square whole square, and b raised to 4 we can write as b square whole square, right? So in between sign plus. So a plus b whole square, first identity. So what is the answer? A square plus b square whole square. That is the factor form. Clear? Now let's see question number 2. Second question is factorize. First question we have used the identity of first and second itself, right? But in question number 2, you can see that only two terms are there. First question is 4p square minus 9q square. So here we can use third identity, a square minus b square. So you can see that 4p square is the square of 2p, 9q square is the square of 3q. So you got a square minus b square, that is equal to a plus b into a minus b. Here what is a? 2p is a. What is b? 3q is b. So that means 2p minus 3q into 2p plus 3q. That is the answer. Clear? Second one, 63a square minus 112b square. Here also two terms are there, but both the terms are not perfect square. A square and b square, okay, that is a perfect square, but 63 and 112 is not a perfect square. But we can see that if we take out one common factor from 63 and 112, we will make it become a perfect square. How? We know that 7 into 9, 63, right? The same way 7 into 16 also 112. then we can see that 9 and 16 both are perfect squares. So let me take 7 as a common factor and keep it outside. Now what is left out inside? That is 9a square minus 16b square. Now we got a square minus b square because 9a square can be written as 3a whole square. 16b square can be written as 4b whole square. 7 is common for, in every step you have to write 7 is common and inside bracket a square minus b square. Here what is a? 3a become a and 4b become b. So we got 7 into 3a minus 4b into 3a plus 4b. Clear? 7 is common for both the terms. Now third one, 49x square minus 36. Here 49x square is the square form of 7x. 36 is the square of 6. So directly we got a square minus b square. That means a is equal to 7x, b is equal to 6. So 7x minus 6 into 7x plus 6. Now fourth one, 16x raised to 5 minus 144x raised to 3. Here also you can see that 144 and 16. So 16 is a perfect square and 144 also perfect square. But x raised to 5, that is not a perfect square. If it is in even number means x raised to 4, yeah, x raised to 2, like that. Then x raised to 9, then we can say that it is perfect, right? Then 144x cube, that is also not perfect. So what we can take? We can take common 16x cube can take as a common because in both the cases 16 into x raised to 5, 16x raised to 5 minus 16 into 9 that is equal to 144. So we can take out 16x cube. Now what will remain out? Inside it is x square minus 9. That means x square is the square of x, 9 is the square of 3. So we got a square minus b square. 16x cube become common there. So x minus 3 into x plus 3. So what is the answer? 16x cube into x minus 3 into x plus 3. Clear? Now fifth one, L plus m whole square minus L minus m whole square. Here L plus m is A and L minus m is B. Clear? So we can write L plus m minus L minus m into L plus m plus L minus m. A square minus b square means first a square minus a minus b into a plus b. Now here if we are taking out means a bracket we can open, then here what will come? L plus m minus L minus into minus plus m. Same way here L plus m plus L minus m. Now take together L and L will cut down here, m and m, 2m will be remain. Here also m and m will cut and L plus L, 2L will be there. So now multiply 2m into 2L, what will get? 2 to the 4, m into L, ml. So 4 ml is the answer. Clear? Here all together you are having A. Here A means L plus M together. Okay. B means L minus M together. So that is why A plus B means together you will get L plus M minus, yeah, plus L minus M, yeah, L plus M minus L minus M. Then after that we can take together because M is like terms are there. So we can add or subtract it together. Right? So the answer is 4LM. Clear? Now question number 6. 9x square y square minus 16. Here 9x square y square means that is the perfect square form of 3xy whole square. 16 is the perfect square of 4. Right? Now we got a square minus b square. Here a is 3xy and b is 4. So a plus b into a minus b, we can write 3xy plus 4 into 3xy minus 4. Clear? Seventh one, x square minus 2xy plus y square minus z square. So x square minus 2xy plus y square means that is x minus y whole square, right? A minus b whole square, second identity. So that we can write like that. Means we can take x minus y whole square is our a square, then minus z square. Here also you have to take a is equal to x minus y, b is z. So a square minus b square is equal to a minus b into a plus b. So first x minus y minus z. Then next x minus y plus z. That is the answer. Now eighth one. 25 a raised to 4 minus 4b square plus 28 bc minus 49 c square. So here we can see that first one, that is 5a whole square, right? Now next section we can put in the bracket, that is 4b square plus 28bc minus 49c square. Because these three terms, if we look for that, first and last we have perfect square and middle term is like as a 2ab. So we can write like this: 4b square means that is 2b whole square, that is our a. 49c square means that is 7c whole square, that is our b. In between minus sign is there, so we can write a minus b whole square. So here 5a square is a and 2b minus 7c whole square is our b. So a minus b into a plus b. That is 5a minus 2b minus 7c into 5a plus 2b minus 7c. Now in second step the sign will change because outside minus sign is there. We have to take out the bracket, so that means minus sign also will multiply with the inside numbers. So here 5a minus into 2b minus 2b. Now minus into minus 7c, that is plus 7c. Then second one same itself, 5a, because outside sign is plus. If we multiply plus with the sign, the same sign will come. 5a plus 2b, 5a minus 7c. So a plus b into a minus b. That is the answer. Answer is 5a minus 2b plus 7c into 5a plus 2b minus 7c. Clear? Now, question number 3. Factorize the expressions. First question is ax square plus bx. Here in this question, we are not using identities. Here we are using first and second type of methods. Okay. So ax square plus bx means we can see that x is common there. So method of common factors we can use here. So x will be take out and inside what's left? Ax plus b. Okay. That is the answer. Now second question. 7p square plus 21q square. Here 7 is common in both because 21 can be written as 7 into 3. Right? So the answer is 7 into p square plus 3q square. Okay. Now third one. 2x cube plus 2xy square plus 2xz square. Here you can see that 2 is common in all the case, all three terms. Yes. X is also common there. Okay. So 2x we can take as common, and what is left out? 2x we already taken. So x square is remaining in first term. 2x already taken. Y square is remaining in second term. 2x already taken. So z square is remaining in third term. So the factors are 2x into x square plus y square plus z square. Okay. Now question number 4. am square plus bm square plus bn square plus an square. Here you can see that 4 terms are there. If it is 4 terms like this, means we have to use regrouping. Identity of, not identity, factorizing by regrouping terms. Okay. So here first and second term we can put it in one group and third and fourth in another group. So from first we can see that m square is common there. So m square we can take as a common in outside. Now what is left out? A plus b, right? Now in second group also n square is common there. N square we can take as a common there. So what is left out? A plus b. Now you can see that here also a plus b is common in both the terms. So that is our first factor. And what is left out? M square plus n square. That is our second factor. So the answer is a plus b into m square plus n square. Okay. Now fifth question. Lm plus L plus m plus L. So here also first case L is common there, isn't it? Group means we can group like this only. L plus M plus L in one group and M plus L in another group. So here first we have taken L outside, then what is left out? M plus 1. L already taken, so 1 into L is L. So 1 is remaining there. Plus M plus 1 is there. Nothing is common. So 1 we can take as a common. So 1 into M plus 1. So here M plus 1 is common and L plus 1 is common. So we got M plus 1 into L plus 1. Okay. Now question number 6. Y into y plus z plus 9 into y plus z. Here nothing you have to do because already the common factors are given there. Y plus z is common in both the group. So that is one factor and remaining is our second factor, that is y plus 9. Now seventh one. 5y square minus 20y minus 8z plus 2yz. So here also we can factorize like this. First 5y square minus 20y together in one group. And second group is our 2yz minus 8z. Now see what is common there. Here factorize means you can see the common factors. 5y and 20y, you can see 5y is common. Now first term y is remaining there. Minus 20y, 5y we already taken, 4 is left out. So 5y into y minus 4. Here plus 2z we can take because here also 2z is there. 8z also we know that is 2 into 4 into z. So 2z we can take out. So 2z is common here. What is left out? Y minus 4. Now you can see that y minus 4 is one common factor here. That is our first factor. And what is left out? 5y minus plus 2z. That is our second factor. So the answer is y minus 4 into 5y plus 2z. Right? Now question number 8. 10ab plus 4a plus 5b plus 2. Here also the same way we can take the factors. Yeah, group. First 10ab and 4a. 2a we can take as common. Now what is remaining here? 5b plus 2. Second group only 5b plus 2 is there. So 1 we can take as a common. So what is the factors? One factor is 5b plus 2. And remaining number that is 2a plus 1 is our another factor. So answer is 5b plus 2 into 2a plus 1. Now last question. 6xy minus 4y plus 6 minus 9x. So here also same way we are regrouping 6xy minus 4y minus 9x plus 6. Okay. So here also you can see that 6xy and 4y. 6xy can be written as 2 into 3 into x into y. Right. Same way 4y can be written as 2 into 2 into y. So 2y we can take as common. Now what is left out? 3x minus 2. Same way here we are taking minus 3. If you are taking minus 3, then you see the sign will change inside, right? So here minus 3 we have taken. Now here it is left out 3x. Then plus 6 is here. From that minus 3 we have taken. So minus 3 into minus 3 that is equal to minus 3 into minus 2 that is equal to plus 6. So minus 2 is left out here. So minus 3 outside and inside 3x minus 2. Now what is common here? 3x minus 2 that is our first factor and what is left out? 2y minus 3 that is our second factor. So the factors are 3x minus 2 into 2y minus 3. Clear? Now question number 4. Factorize. First question is a raised to 4 minus b raised to 4. Here you can see the power is 4, right? That means square whole square. That means 2 times, whatever may be here, we are doing 2 identity. Means same identity 2 times. Let's see. So first a raised to 4 means a square whole square. B raised to 4 means b square whole square, right? So first we can use a square minus b square is equal to a plus b into a minus b. So here a is a square, b is b square. So a square minus b square into a square plus b square. Now again you can see that we got a square minus b square. Now again we can factorize this. A square minus b square is a plus b into a minus b. Then a square plus b square should be same itself. The factorization form of a raised to 4 minus b raised to form is a plus b into a minus b into a square plus b square. Right? Now second question, p raised to 4 minus 81. The power is 4. Then that time you see, here we have to do the same identity 2 times. Let's see. Here p raised to 4 can be written as p square whole square. 81 can be written as 9 whole square. Yeah, otherwise we can write it 3 raised to 4. Same way, p raised to 4 minus 3 raised to 4. No need, we can do directly 9 square. So first we can take p square minus 9 and p square plus 9. Now you see p square minus 9. It can be written as p square minus 3 square. 9 is the square of 3, right? So a square minus b square again we got. So expand that p plus 3 into p minus 3. Then what is left out? P square plus 9. So this is the factor form. P plus 3 into p minus 3 into p square plus 9. That is the factor form of p raised to 4 minus 81. Okay. Now fourth one. X raised to 4 minus y minus z whole raised to 4. So here x raised to 4 can be written as x square whole square. Okay. Now here y minus z, that is our b. So inside the bracket you can write y minus z whole square and whole square. Again one more square is there. So our a is x square and b is y minus z square. So first we can write x square minus y minus z whole square, x square plus y minus z whole square. Now here a minus b into a plus b. So here x minus y plus z. How it is coming? Minus into minus plus will come. Okay. X minus y plus z into x plus y minus z. A होगी a minus b into a plus b. Now last x square plus y minus z whole square. That thing we can put same. So this is the answer. Now question number 3. X raised to 4 minus y plus z whole raised to 4. Here also x raised to 4 can be written as x square whole square minus y plus z whole raised to 4 can be written as y plus z whole square and again whole square. Okay. So a square minus b square, first we can take that identity, a minus b into a plus b. So x square minus y plus z whole square, x square plus y plus z whole square. Now x square minus means a square minus b square is here, right? So again write a minus b into a plus b, that is x minus y plus z, x plus y plus z. Then second identity same, second term same itself, x square plus y plus z whole square. Now here minus sign will change, we are multiplying minus with the plus sign, so it will change as x minus y minus z, and second term is x plus y plus z, and third one should be same, no change. Clear? Now question number 5. A raised to 4 minus 2a square b square plus b raised to 4. Here a raised to 4 and a square, 2a square b square is there. Isn't it? Now we can split this one like this. Minus a square b square minus a square b square. That is, if we are adding together, we will get a minus 2a square b square plus a b raised to 4. That means from here we can take a square common, that is a square minus b square inside. And from here we will get minus b square common and a square minus b square inside. Now we got one factor, that is a square minus b square, and second factor a square minus b square. Means the same, a square minus b square into a square minus b square. Now here a square minus b square whole square we got. Isn't it? Because 2 times a square minus b square is there. So that means a minus b into a plus b square, and that means a minus b whole square into a plus b whole square. Right? Means here both are coming 2 times. So a minus b into a plus b and a minus b into a plus b. That means a minus b whole square into a plus b whole square. That is the answer. Clear? Now, question number 5. Factorize the following expressions. Here first question, you can see that p square plus 6p plus 8. Right? 3 terms are there. But any 2 terms are having perfect square? P square, okay, that is the square of p. But 8 is not a perfect square. Isn't it? So that is why it is not fit for our first and second identity. Right? But we are having a special identity, that is x plus a into x plus b. That is equal to x square plus a plus b into x plus ab. Let's see. Means here, if we multiply 2 numbers, that is a and b, we should get 8. The same number if we are adding, we should get 6. What are the numbers? Let's see. 2 into 4, that is equal to 8. 2 plus 4, that is also 6. Right? So here we can take 2 plus 4, that is 6, and 2 into 4, that is 8. So which identity we can use? X plus A into X plus B. So P square plus 6P plus 8 can be written as P square plus 2P plus 4P plus 8. 8 means 2 into 4. Now we can regroup this. P square plus 2P in one group, 4P plus 8 in another group. So first group we can take P common, and what is left out? P plus 2. And from second 4 we can take common, and what is left out? P plus 2. Now we got first common, that is our first factor, that is P plus 2. What is left out? P plus 4, that is our second factor. Yeah, directly also you can say that 2 and 4, that means 2 is our A and 4 is our B. So X plus A into X plus B, both are positive sign. So directly we can say that P plus 2 into P plus 4. Correct? Now second one, Q square minus 10Q plus 21. Here you see minus sign is there. That means if we multiply, we should get 21. That is plus 21. So that means both the numbers may be negative. Right? Minus 3 into minus 7. Minus 3 into minus 7 plus 21. Minus 3 plus minus 7 minus 10. So that is correct. Right? So we can write like this, 3 plus 7. That is minus 3 plus minus 7. That is equal to minus 10. 3 into 7, that is equal to 21. So we can write like this, Q square minus 3Q minus 7Q plus 21. Now regroup. So first group, Q can be take common, then left out Q minus 3. From second group, minus 7 we can take common, and sign will change. Let's see. Plus 21 minus 7 we already taken, then minus 3 is left out there. So Q minus 3 inside. Now first common factor we got Q minus 3, that is our factor. And second remaining thing, that is Q minus 7, that is our second factor. Or one more thing, here A is minus 3, B is minus 7. So X is Q here. So Q minus 3 into Q minus 7. Clear? Same way third one, P square plus 6P minus 16. Here if we are multiplying, we are getting minus sign. That means one is positive and another one is negative. At the same time, you got a plus 6. That means a subtraction. One is plus and one is minus, means a subtraction done here, isn't it? So we can see that greatest number should be positive, right? So that is why plus 6 came. So plus 8 and minus 2. So 8 2 is 16, plus into minus, minus 8 minus 2, that is 6. So A will be 8 and B will be minus 2. So our answer will be P plus 8 into P minus 2. Let's see how it is coming. So we can write it like this, P square plus 8P minus 2P minus 16. Now grouping first and second. From first group P we can take out, and P plus 8 is remaining there. From second group 2 we can take out, then P plus 8 is remaining there, because minus 16 minus we already taken, so plus is remaining there. So now common number here, P plus 8, and second one is P minus 2. So our factor form is P plus 8 into P minus 2. Clear? Nothing you have to see. You have to see that if we are multiplying, then AB is our multiplication, and the same number if we are adding and subtracting, we should get a X plus A and X plus B, means A plus B into X. So what is A, what is B? If you got direct, then directly you can write the answer here, right? In every case, you can see that if A is 2 and B is 4, then that means P plus 2 into P plus 4. Same way here, minus 3 and minus 7. Minus 3 is our A, minus 7 is our B. So Q minus 3 into Q minus 7. Same way here, plus 8 is our A, minus 2 is our B. So answer is P plus 8 into P minus 2. Clear? Very simple, right? Okay. Here we are winding up this session. Okay. So we have completed exercise 14.2. So note down all the questions in your notebook.